Hello everyone, welcome to the computer aided drawing course. In this video we're gonna continue the 3D modeling that we started over the previous video. The last video we already discussed the basic or the standard shapes and how we practice how we can create these 3D solids, these standard shapes using AutoCAD. Also we discussed how we can switch the different views and how we can switch from 2-dimension to 3-dimension, how we can switch the workspace as already given here from 3D basics, 3D modeling or drafting and annotation. Since we are interested in 3-dimensional, so this is, you can either work over the 3D basics workspace or the 3D modeling, it's up to you. So what we're gonna do through this video, I'm gonna explain to you the most important commands that would be used for creating 3D solids, which are the Extrude Command, the Revolve, in addition to the loft and sweep. These loft and sweep, these are two more advanced commands that would be used for more complicated and advanced 3D solids. We can build these things using the loft and sweep. So we're gonna go over these four main commands in addition to the press pull. This is gonna be, or we're gonna discuss the other commands in another video. But the main objective here is just to explain these main four commands and understand how we can use them for creating 3D solid. The Extrude and Revolve command, you could say that these are the main fundamental commands that would be used for any software for 3D modeling. Like if we're going to talk about SolidWorks, Solid Edge, we are using the same commands, even with the same name, like Extrusion and Revolution or Revolve. So these commands are fundamental thing. The basic idea of the Extrude command, and this is the first one that we're going to start with, that as already shown here in the preview, that your objective is just to draw a 2-dimensional sketch and you're gonna extend it with a certain way. It is very similar like you're gonna draw a box. If you remember, when we draw the box, we draw like a rectangular base, then we extend it with a height. It's gonna be typically the same objective or the same idea. Also very similar like cylinder. To create a cylinder, we had to draw a circle, then we extended this circle with a specific height. Remember, we mentioned in the previous meeting that to create an object, to create a 3D solid, we have to start with a 2-dimensional sketch first, then we're gonna extend it or we're gonna revolve it or do loft or sweep. So we're gonna loft or sweep. So these are the different commands. The objective of these commands is to convert a 2-dimensional sketch into 3D model. So we should have a 2-dimensional sketch first to apply any one of these commands. Make sense? This is what will be explained through this today's video, starting with the extrusion command. So extrusion, as I mentioned, the key idea that you are going to extrude or extend a specific 2-dimensional sketch, whatever it is, in one direction, in a specific direction, with a certain manner or a certain approach, as I'm gonna explain. For example, let us initially, I didn't even choose extrude. Your objective is just to draw any 2-dimensional sketch, whatever it is. So I'm just gonna draw one line from 0, 0 point, like you're gonna work in 2-dimension. Assume that we do have this 2-dimensional sketch with a length 100, and then I'm just gonna jump up here with like 100 as well. Then we're gonna have another 100 to the left, and I'm gonna close the shape with 100. So this is like a square. And let us even apply like fillet at the apply the fillet command, and I'm gonna specify the radius of the fillet, let's say like 20 at this corner, and it's gonna be multiple at these corners in this way, like I'm applying at these two corners this fillet, and press enter. So this is simply a 2-dimensional sketch. Whatever it is, we can add more complication, like I'm gonna draw a line, for example, from this point, F8, just deactivated. I'm just gonna trim this one, then I'm gonna use the trim command to trim the shape, this shape in this way. So how about if we have this 2-dimensional sketch? We can extend it. So assume that this is like the base of a building, a base of a solid object, then you are going to extend it in certain direction. If we decided to look at it in the 3-dimension, it is still 2-dimensional sketch because we didn't use any one of these commands of the extrusion or whatever. We just did two-dimensional sketching. So your objective is just to extend this one in this direction, standing up or extending it down. It's up to you. We can specify this direction. So how we can extend this object? We have to use Extrude Command. So the Extrude Command, it is simply used for extending two-dimensional sketches in one direction, either up or down. Make sense? So we drew a two-dimensional sketch. Now we would like to extend it. But there are some things that we have to do, and there are some points that we have to demonstrate here. That this two-dimensional sketch, it is conditional. So what does it mean? To end up with a solid, this two-dimensional sketch first, it should be closed. It should be closed loop. So what does it mean, closed loop? If you started from any point and move all the way, you're gonna reset back again to the same point. You can start from here and move this direction, or even the other direction, you're gonna return to the same point. So it means that the sketch, generally, it should be closed loop, as already given here. Make sense? And another thing, that there is no intersections to the loop. Or this, assume that this is like a drawing area, and there shouldn't be any intersection to this drawing area. For example, if there is a line here in the middle, this is an open loop. Why? Because this loop, all of these different shapes present a closed loop, but this line is an open loop. If we decided to do extrusion to all of this two-dimensional sketch, it won't gonna be extruded. There is no extrusion in this case. Why? Because we do have two loops, which all of these lines are forming one loop, but this loop is closed, so that is fine, it will be extruded. But this one, it won't gonna be extruded. Why? It is open loop. Also, there should be intersection. There is an intersection here. It is not recommended to have such intersection, but with respect to AutoCAD, it's gonna be extruded as well. But for example, I can add here like this triangular shape. So I'm closing this loop. So now I do have two loops. One loop with this triangular shape forming one closed loop, and there is another closed loop, which is these lines, all of them together. If we applied extrude to these two loops, we're gonna end up with two standing objects. Like you already having two solid objects, and definitely they're gonna be two separate solid objects. They won't gonna be one object unless you union them or combine them as a single object. But initially, with respect to AutoCAD gonna deal with them like two separate objects, as I'm gonna show you. So there is a condition here that the thing that should be extruded, it should be closed loop. If you decided to extrude something that is open loop, you will not be ending with a solid, and instead you're gonna end up with a surface. It's gonna be just one surface, but it won't gonna be a solid object. Make sense? This is one thing. So let us work over the first loop first, this one. So it is a closed loop, so we can extend it. But before you extend it, you have to join all of these elements, because with respect to AutoCAD, this line, it is an object, this line is another object, this line, this curve is another object, and so on. So all of these are multiple objects. You have to combine all of them into one single object so you can apply the extrude. So the extrude, to end up with a solid, first, there are two main conditions. The first condition is that the two-dimensional sketch should be closed loop. The second condition, that all the objects, all the lines and the curves within the two-dimensional sketch should be joined as a single object. Now what we have is multiple objects. I can apply extrude to these multiple objects, but if we did, we're gonna end up with surfaces, not a solid object, as I'm gonna show you. So what I've did here, I've chosen all the object, then I'm gonna click on extrude. Then automatically AutoCAD gonna ask me one question, gonna request one thing, is to specify the height of the extrusion. So I'm just gonna give the height of the extrusion, let's say like 200, and press enter. So now I end up with a solid thing, but it is surface. So if we move to the three-dimensional sketch, and even we switch to this shape, so as you can see, we end up with solid object, but it is not solid, it is empty, there is cavity. These like four surfaces, like multiple surfaces. Even these are not walls, there is zero thickness for all of these surfaces. These are standing walls with zero thickness. Why? These are originally surfaces. So this is one of the methods of how we can build surfaces using AutoCAD. This is not the objective of this course or even of mechanical engineering application that all the time we build solids. We are not building surfaces. So for this case, this thing, it won't gonna work for us. It means that the extrusion command, it is not in the proper shape that we would like to have it. We need it as a solid object. So this happened because we missed one step in between. This step that we considered, we dealt with these lines as separate objects. So AutoCAD extended each one of these lines as a surface. But if we joined all of them together into one single object and we use the extrusion command, we're gonna end up with a standing solid object. Make sense? So how we can join them? Simply you're gonna use join command, the same name. So if your objective is just to choose all the two-dimensional sketch that should be closed loop, then your objective is just to type join in the command window or directly down here and press enter. So now if you try to choose any point, click any point over the loop, it will be choosing as a single object. Now I'm dealing with this one like single object. Now if I choose this one and press on extrude, AutoCAD gonna ask me to specify the height of extension. So I'm just gonna give extension, let's say with 100 height and press enter. So now if I move to the 3D solid, I can see as a solid. It is not a surface, it is bulk, solid thing. Everything is metal, everything is solid. Even you can switch to be realistic in this way, so you're gonna see like a solid object. Make sense? So this is the key idea of the extrusion command, that it converts any closed loop two-dimensional sketch, and this two-dimensional sketch, it should be joined. If it is not joined, you're gonna end up with surfaces. You have to join the lines first, then you're gonna extend them in one direction with a specific way to end up with a 3D solid. This is the basic idea of the extrusion command. Make sense? How about if we do have multiple loops? Can we extend them? Yes, we can extend them at once. So we reset back here, assume that this is one loop, assume that we do have another loop of this shape, like one line and this triangular shape in the middle. So if we decided to join all of the shape, I'm just gonna type join here and press enter. So we're gonna end up here with two loops. This loop is a single loop, so when we extrude it, we're gonna end up with a standing solid object. And this is another loop. When we extrude it, we're gonna end up with another solid object. What I'm gonna do here, I'm just gonna change the color. I'm gonna try to change the color. Forget about it for now, and let us just extend these two loops. So as we mentioned, this is just two loops. So we can end up with like two standing objects. So if I apply it for these, if I choose the two loops, both of them, then I press on extrude. He's gonna ask me about the height, how much it is. Then you're gonna specify the height, so you're gonna find something that already standing with the height, let's say 100. But remember that these are two standing objects, not just one. So when we're gonna see, as you can see, there are like two standing things. If we change here to the realistic, for example, or this shaded, you're gonna find like this triangular shape is already inside the other solid object. Okay, we can even change the color of this one, or we can do other things with the other objects. So you could consider that this is like two concrete parts that already fell together, but they are two separate objects. So we can move one with respect to the other. I'm gonna show you something here, then we're gonna explain this point with more detail. Like for example, I can extend and shorten one of the lines. Like I'm gonna shorten this one. So as you can see, we do have one object and there is another object. What I've did here, I edited over this solid, I shortened this solid. This editing thing, we're gonna discuss them later, okay? But the objective now, the key idea of the extrude command, if we do have multiple closed loops and they are joined and we extended them, we're gonna end up with like multiple objects, solid objects. Even if I move this one outside the object and I decided to extend both of them, extrude both of them, and he asked me to specify the things that will be extruded. So these are the two objects. So You do have to apply extrude. You can, for example, choose extrude first, then you're gonna choose the loops, the objects that will be extruded. So you can choose like the object, like you can click on the extrude first, then you're gonna choose the object that will be extruded, then you're gonna extend them. This is one option. Or you can choose the object first, these two-dimensional loops, then you're gonna click on extrude, then it's gonna ask you to specify the height, let's say like 200. So we're gonna end up with like two standing objects next to each other, but they are not merged. They are two separate objects but merged together, like standing next to each other, right? So this is simply how we can apply the extrude command for creating three-dimensional solid. The key idea that we should have a two-dimensional sketch. This two-dimensional sketch should be closed loop and joined. If it is not joined, if you forgot the join step, you're gonna end up with surfaces. Surfaces mean that you didn't join these loop together. One of the other challenges or difficulties or problem that many of you already facing while they try to join these different lines. So these lines already joined, like all of this loop is just a single loop. How about if you would like to extrude it back, like separate these lines back again? So if you choose the loop which is already joined, you can extrude it. Like extrude, you're just gonna type extrude and press enter. So you're gonna end up with these lines separate one more time. Then you can join them back again and extrude. It's up to you. So extrude command, it will extrude the object that already joined into multiple objects back again. Make sense? So if we do have these different lines, one of the things that I was insisting while we were practicing two-dimensional sketches that don't have lines that is over another line. For example, assume that we do have all of this line, we created this shape, but for some reason we draw another line that is on the top of this line. So here we do have two different lines, one short line and there is another line here. If you try to combine, so definitely I don't see the other line. This other line, this line here, it is not seen, but it is still there. So if I try to choose the shape in this way and type join, it might be not joined. So I type join and I try to join the shape. I got the loop, but within this loop would have another object here. There is another line that already joined. So there is a problem with this line now. So this problem will be shown in the extrusion, or probably this line will not making the shape to be joined. So if I try to do extrusion to this object and press enter, as I try to select the object and press enter, he gives me like one object remove, like cannot sweep or extrude a self-intersecting curve. Self-intersecting curve, it means that this is not a closed loop indirectly. Why? Because of this little small line that I forgot it when I was creating this two-dimensional sketch. So that's why I was insisting all the time, if you use any line to assist you to locate a point, you have to remove it. Don't put two lines over each other. This, when you join the loop, this, and you're gonna apply either revolve or loft or sweep or extrusion, these commands will not be applied because of this extra line. This line should be removed first, you have to delete it. Then now you can join the loop, join all of these lines together into one loop, join. Then you can use the command window. Even you can apply the command window in 3 dimension, no problem. You can work in 3 dimension and choose the loop, this closed loop, but after join, then you can extend it up, or even you can extend it down the same way by giving the height. I can extend it down by 20, so it will be extended down. So if you would like, if you are interested in specifying the direction of the extension of this cross section or this 2-dimensional sketch, it is better, it is advised to work on the 3 dimensions so you can see the direction and identify the direction of extension. Make sense? Also, this is not it for the extrusion. Extrusion, there are lots of options. The default thing that we already extruding this section in one specific direction, vertical, perpendicular to the cross section. whatever in the top, going up or going down, in one direction, up or down, but it is perpendicular to this line. But we can do other things. There are more other things that we can do using extrusion. We can play or adjust the way of extruding this object. How? One of the options, for example, even it's going to be much more clear if we work in 3-dimension. I'm just going to choose extrude to this sketch, and then I'm going to press enter to confirm my selection for the object. Then he asked me to specify the height. No, I won't gonna specify the height. There are some other options here that we can use. One of the things is taper angle, that instead of extending it with the same height, with the same perpendicular direction, with the same width, we can give it a taper, like inclination. So if I choose a taper angle like this one, he's gonna ask me to specify the taper angle. By default it is 0 as shown here, but we can make it like, let's say 45 or 20 degrees. Let's say like 20 degrees angle, and press enter. So as you can see, as you extend, it is tapered, it is inclined, it is not standing, it is have inclination or taper as we extending it up. So it's gonna take, it might take the shape of the pyramid shape, or we can extend it in the other way. Okay, but it is tapered with an angle of 20 as we specified down there. So once you specify the angle of taper, he's gonna ask us to specify the height. Then we can specify the height, let's say like 50. So we're gonna end up with taper shape as already shown here. Make sense? So it is not extending, it's standing. No, it is tapered. All the cross section had been tapered. This is also one of the options of the extrude command that we can apply. Also, one of the things that we can extend following a path. For example, by default, we're already extending vertical. No, we can extend it following a curve. Like instead, for example, how about if we would like to extend this cross section but following a curve? So we should have another sketch of the path because we would like to extend it following a specific path. So we have to draw the other path. So what we're gonna do here, we're just gonna draw, going back again to the, since we're gonna work in 2-dimension, it is advised to go back again to the 2-dimension. Go to the top view one more time, to the XY plane. Then, what you're gonna do, you're just gonna draw a path. I'm just gonna draw a line. Let's say I'm just gonna start with a curve, or I'm just gonna draw a line from this point. I'm just gonna consider this is like a reference point, or even you can start from this center point. Let us start from this center point here of the shape. Then I'm just gonna go like this line. Then I'm just gonna go to horizontal this way. Then I'm just gonna go to vertical and any specific path, whatever it is. Then I'm just gonna give a little bit curvatures to these different lines. So let me just extend it somehow. So I want it won't gonna give me an error. Like assume that this is gonna be the best that we're gonna use for extending or extruding this cross section. Like we have to extrude it following this path, and we're gonna give like some fillets and curvatures for this with a radius of, let's say 100 at this corner. 100 is too small value, so let us use fillet. With radius, let's say r equals 500, and between this line and this line, and let us make it multiple between this line and this line in this way, and this line and this line, for example. Okay, so assume that this is a path. I'm just gonna join this path as well. So I'm just gonna select this path. I'm gonna join in this way to be like a single path. So I should have two sketches. Going back again to the 3-dimensional direction here. So this should be the cross section, and this cross section should keep following this path. But as you can see, we do have both of them, the path and the cross section, both are located over the same plane. Make sense? Observe that both the sketch that it will be extended and the path that this cross section will follow, both are located over the same cross section. There's something will happen in this case. So if I try to apply extrude of this object following this path, so I'm just extrude, choose the object and press enter to confirm that you choose the object. Now it will be extended in one direction perpendicular to the object. No, I would like to have it following this path, right? So to follow a path, you have to choose path here, this option, or type P and enter, P and enter. So it means that you're gonna ask AutoCAD, no, I won't gonna extend it in this direction, I need it to be extended following this path. Then it's gonna ask you to select extrusion path. So if I choose this path, now if I clicked on it, I end up with nothing. As you can see, enable to extrude the selected object following this path. While the main reason is that both the sketch and the path both are located over the same plane. And this is the problem. It means that to extend it should be extended, projected out of the section. It should be projected out of the section. Both they shouldn't be in the same plane. So the question is how we can draw multiple sketches over multiple sections or multiple planes. We do have here the XY plane, this is sketch, and we do have other like XY, YZ. So for example, to be extruded, we should have this sketch already drawn in the XZ plane or in the YZ plane, so this cross section would follow it. And this would require changing the UCS, which is the user coordinate system, that we have to change this coordinate system. By default, as we mentioned in the previous video, as long as we have this a little bit small box in the coordinate system XYZ, this indicate, and this small box is located over the XY plane. By default, all the time, AutoCAD draws only over the XY plane. This XY plane is aligned to the top view, or it would be aligned to the left or box or back view or front, it's up to us, but by default it is aligned to the top view, and all the time the only plane that we are allowed to plot or draw over it is only the XY plane. So we would like to change the direction of this coordinate system. How we can change the direction of the coordinate system? To do it, basically you're gonna use coordinate. This panel here, there are coordinate, there are world, and there are lots of things. The best option, actually, there are lots of methods of changing and playing with this coordinate system. The easiest way, well, I'm just gonna give you two approaches, two methods. One of the methods is just to use 3 points. This is the easiest way. Your objective, if you clicked on this one and read the instruction, as you can see, the UCS has been moved. The coordinates are moving, right? Where you gonna locate them? So the first thing is gonna ask you about the 0 point, where it is. So I'm just gonna keep it where it was, the 0 point, the 0, point. Then it's gonna ask you to click 1 point directed in the positive X. Your objective is 3 points. It means that you're gonna specify where is the positive, where is the 0 point, where is the origin point, and one click over the positive direction of X and the positive direction of Y. So for example, I'm gonna make this X, this is the positive X, and I'm gonna make the positive Y is up. Make sure that the ortho mode is activated. Make sure that the ortho mode is activated. So if you clicked up, I moved, as you can see, I moved the XY plane. Initially, the XY plane was in this way, over the horizontal plane. Now, when I move the UCS, again, I'm just gonna repeat it, 3 points. Make this the 0 point, 1 point over the positive X, 1 point over the positive Y. This is gonna give us the, like we already moved the XY plane to be vertical, standing, or instead of being horizontal. Now, if I remove this thing and I reset back again to the top view, I'm gonna return back again to the top view. Repeat that again. So we already got here the XY, right, over the top view. By default, AutoCAD sticks to the XY plane or aligns by default the XY plane to the top view, but we can change this alignment, but it is not necessary actually since we're already working in 3 dimension. So your objective again, what I've did here, I just switched the XY plane in the 3-dimensional thing to make it perpendicular to the main section, because I should have the path perpendicular or in a plane that is perpendicular to the plane of the section itself or the sketch itself. Now if I move to the top view, I move to the 2-dimension, now I can draw the sketch of the path. So I'm just gonna draw one line starting from this point going up. This is gonna be in this direction, then in this direction, and so on. So assume that this is the path, and then I'm just gonna add some fillets here, multiple with the same radius, let's say like between these, like to make it smooth. So I'm gonna end up with like kind of error or something because of if the intersection of the switch, like if there is a step corner here, probably AutoCAD won't gonna able to give rotation of the section because this section will be rotated following this path. So try to make it like curved, and definitely I'm just showing you how we can apply this thing. But in the real application, you should have specific dimensions of this path, so you have to stick to it. So assume that we would have this fillet here of radius r equals, let's say like 100 between these two lines in this way. Then I'm just gonna combine this path, join, choose all of this line and join them, then work even, let us see it in the 3-dimension. So now even if I give it like a little bit rotation, as you can see in this direction, like we'd have the cross section and this crochet should be keep following this path, right? So how we can do it? Simply if we choose extrude of this cross section and press enter, it would be extended in one direction. No, I don't want to extend it in this direction. I want to extend it following a path. So choose path here, click on it and choose the path. So it will be extended following this path as will be seen in the 3-dimensional way. So this is gonna be the final object. Like you do have the cross section, and this cross section is just keep following the path in this way. Make sense? So this is simply how we can create an extrusion following a certain path. Also we created the extrusion following a path as tapered. Can we follow the path with a taper, both of them? Yes. So we explained how we can extrude with a taper angle. Then we explained how we can extrude following a path. We can do both of them. We can follow a path and extrude and taper in the meanwhile. So if I repeated this thing, so I'm gonna extrude this cross section, choose the cross section, then press enter. Then what? Your objective is just to, I'm gonna choose path, or you can define the taper angle first. Define the taper angle, let's say like 2 degrees or 5 degrees taper angle. Then I'm just gonna ask him to follow this path. I'm gonna choose path, then follow the path. I'm getting error unable to extrude because the taper angle is too big angle to be extruded. So we're gonna end up with, we're gonna be able to finish the path. So, but if the path is short or the angle is small, it will be extruded. So let me repeat it again, following another angle. So let us choose like taper angle of, let's say like 1 degrees, and following this path in this way. It won't gonna be able to do it. So the key idea, the problem with this, that the angle and the length of the path, they should be consistent. The problem is that the angle with the path, they are not consistent. So that's why we're already getting this inability to extrude it over the path. This is for the extrusion command. Now let us move to the revolve. Let's see how we can do revolve for objects, and let us reset back again. How we can reset these UCS, the coordinate system? We can press on world, so it will be reset back. If you press on world, the coordinate system reset back to the thing of the XY plane is aligned to the top view as usual, and you already aligning the coordinates or reset them back again. Okay, if you pressed on the world. Now if we decided to work over revolve, So what is the difference between extrude and revolve? Extrude, you're gonna have a cross section and you're gonna extend it with a certain way. But revolve, you have a cross section and instead of revolving it, extending it, you're just gonna revolve this cross section. You're gonna give it rotation to end up with an object. Like I'm gonna give you an example. Let us consider this triangular shape. This very simple example of triangular shape with lengths, let's say 50 and a height, this is gonna be like 80, and just assume that we do have this two-dimensional sketch of this triangular shape. Then I'm just gonna join the same thing. You should have cross section. It means that all of these lines, they should be joined together in one single object. So I'm gonna choose them, then I'm just gonna type join. You should have one closed loop cross section. So if this is the cross section, and instead of using extrude, I'm just gonna use revolve. So if I decided to revolve the shape, choose the shape and press enter, then it's gonna ask you to draw an axis of rotation. If you're gonna give rotation to an object, it means that you have to specify an axis of rotation. So let us choose that this line, this vertical line, is the axis of rotation. So you're gonna click one point and another point to draw like a line, because to have an axis, the axis should be a line. Like you're gonna 2 points to draw a line. Then it's gonna ask you to specify how long in terms of angle, what is the angle of rotation that you're gonna give to this cross section. Like it looks like you're gonna repeat this cross section multiple times over the 360 degrees, so you're gonna end up with a shape. So if I rotate 360 degrees of rotation and press enter, we're gonna end up with a shape. Definitely, if we're gonna look at it in 3 dimensions, this shape will be seen as a conical shape. This is a cone. Why cone? Because the cross section was a triangular shape and we give it a rotation about a certain axis. This provided us this, or give us this 3D solid. This is simply the basic idea of revolve, that you should have a cross section. This cross section, if you're gonna give it rotation, you're gonna end up with a specific shape. So simply, if you do have a triangular shape with 90-degree upright triangular shape, and you're gonna give it rotation about this vertical line, you're gonna end up with a conical shape. Make sense? Why? Because simply, if I ask you to give rotation to this line, horizontal line, it will be represented like a circle. And this inclined line will give us like a conical circle. So we're gonna end up with a conical shape. How about if I decided to give rotation about another line? Assume that we're gonna give it rotation about this vertical line here. This another line here, this one. I won't gonna rotate it over this, any one of these lines. No, I can rotate it, give a rotation, or the axis of rotation is a different line. So we're gonna end up with a totally different shape. So if I give rotation or revolve to this cross section and press enter, then it's gonna ask me about the axis of rotation. I'm gonna choose this line at the axis of rotation, and then I can rotate with 360 degrees. So we're gonna end up with another object, with another shape. In 3 dimensions, it will be this way. Like as you can see, it has like a cavity. It is like empty thing. It is like a cup, but it has like internal conical thing. Make sense? So this is another shape. So revolve, the object that will be produced by revolve depends on 2 things. What is the shape of the cross section, plus what is the axis of rotation. The shape will be different if you did changes in either one of them. The axis of rotation, if you choose a different axis of rotation, definitely you're gonna end up, for the same cross section, you're gonna end up with a different object. If you change the cross section, definitely you're gonna end up with a different object. Make sense? So how about, for example, the same cross section, the triangular cross section, but we're gonna give it rotation about another line, like another line that is already here. It is way away from the cross section itself. So revolve of this cross section, choose the cross section and press enter. Then it's gonna ask us to specify the axis of rotation. So I'm just gonna choose this axis of rotation. 2 points over this axis. Then I'm gonna give the angle of rotation 360. So we're gonna end up with like a conical shape, but it is empty in 3 dimensions. So it will be seen in this way. Like if we're gonna look at it, it's gonna be like internal hole inside this conical shape. And the interesting thing that the radius of this hole equal to this distance that we give between this axis, line axis, and the triangular shape. If we reset back again here, the radius of the internal hole will equal to this distance. The distance from this point to this point. How much it is? This perpendicular distance, this is gonna give us the radius of the circle, the internal circle of this hole. Make sense? Also, we can give it rotation. It means that we can, if we just move it a little bit inside, so we're already decreasing the radius of the circle. And if we give it rotation, like revolve of this cross section about this axis, and instead of giving rotation by 360 degrees, we're gonna give it rotation, let's say 180 degrees. So it's gonna be like half of the conical shape. We won't gonna complete the circle. It won't gonna be completed. It will be just half of the shape as shown here. As you can see, this cavity inside it, this opening here, this radius equals to the distance that we give to this line from the cross section. If we're gonna look at it from this view, from this bottom view, this is the triangular shape, this side, and this side is the triangular shape, and this is the center line of the shape that we already provided. So we draw half of the shape and we give it rotation 360 or a specific angle, in this case 180 degree, we end up with this 3D solid. So this is the basic idea of the revolve command, and this is the default thing, and this is the fundamental thing, and this is what we basically use all the time for the revolve command to create objects. Make sense? So we extruded we explained the extrusion. The extrusion works as I mentioned by extending cross section, whatever perpendicular or following a path, tapered. Also we explain how we can do revolve for objects by giving them rotation. For example, another example on the revolve. How about if we would like to build a cylinder by revolve? Building a cylinder by revolve, your sketch. So we can build the cylinder using extrusion or revolve. If you decided to build a 3D model of a cylinder with a radius 50 and height 100, what will be the sketch? If you're gonna use extrude, the sketch will be circle with a radius 50 and the height will be 100. But if you decided to use revolve to create the cylinder, the cross section will be rectangular shape and it will be rotated. So it depends on the command that you're gonna use. You can draw, the sketch will be depending on the command that you're gonna use. So for example, I'm gonna show you how we can create a cylindrical shape with a radius 50 and height 100 using the two methods, the extrude command, and then I'm gonna explain with the revolve. So if I decided to build a cylindrical shape or a cylinder with a radius, the base radius of 50 and height 100, we decided to use extrude to do it by extrusion command, we have to draw a sketch, and for this case, the sketch should be circle. So I'm just gonna use circle command, C and enter. And then it's gonna ask us to specify the 0 point. So the 0 point is gonna be 0, 0 and press enter. Then the radius is gonna be 50 as we agreed. So this is the circle. Then even you can work in 3 dimensions, so we're gonna see the extension of the cylinder. So I'm just gonna choose the circle and I'm going to extrude it. I'm using extrusion to extend it with 100 height as I mentioned. So now I got a cylinder with radius, the base radius is with 50 and the height is 100. Can I do it by revolve? Yes, but the sketch will be different. Remember, in the extrusion, the sketch was circle and extended by 100. In the revolve command, the sketch definitely will be different. I won't gonna use a circle. I won't gonna draw a circle. Instead, I'm gonna draw half of the projected rectangular face or the projected view of the cylinder. If you remember in the projection, we said that cylinders will be seen as circle in one view and in the other view will be seen as rectangular shapes, right? So your objective is just to slice or draw half of the cylinder. in the projected view that will be seen as rectangular. So you're gonna draw half of the rectangular shape. For example, if the cylinder, it has a radius of 50 and the height is 100, right? So if I ask you to draw the projected view or three projected view of the cylinder, in one view the cylinder will be seen as a circle, in the other two views will be seen as a circle with a radius 0, 0, for example, with a radius of 50. This is one view. The other two view will be seen as rectangular shape in this way, like horizontal, with a length 150, and from the other view will be seen, as well, like this way, with width 50 and the height is gonna be 100, right? So if you decided to do extrusion, you have to draw this. This is gonna be your sketch. If you decided to work as revolve, your sketch will be half of the rectangular shape. Forgot about this one because I needed standing, so I needed vertical. If you need it horizontal, you're gonna work over this projected view. If you need it vertical, so you're gonna work over this one. Then what you're gonna do? Your objective is just to slice it into halves, two halves. Or simply, you can work even over this one, but simply if we slice this one from the midpoint to the midpoint, then you're gonna use trim to trim this extra portion. To trim this line. Then I can remove this line. So this half, this is the thing that should be revolved, and it will be rotated about this vertical line. But remember that it should be joined because these are multiple lines. So you're gonna choose join. Then I'm just gonna choose revolve of this object and press enter to confirm your selection. Then you're gonna pick 2 points over the axis of rotation, and then you're gonna give it rotation with 360 degree. So we're gonna end up with the cylinder standing, typically the same way as we did with the previous one. This is gonna be the cylinder in this way. As we did with the extrusion, we got the same cylinder but using revolve. So as you can see in the revolve, we use a different sketch, which is different than the extrusion sketch. For the extrusion, we draw circle, but for revolve, we draw half of the rectangular projected view of the original cylinder. Make sense? So this is the basic idea of the extrusion and revolve commands and how we can use them for building 3D solids. These two commands are the two essential commands that you're gonna use for any three-dimensional modeling of 3D solids using AutoCAD. Make sense?